In this video, we will study the motion of a falling cork attached to a piece of paper acting as a parachute. The aim of attaching the parachute was to increase the drag force. As we can see from this video, the cork falls vertically only for part of the motion, and it is this part which we are going to analyze in Tracker. The calibration stick in Tracker was set at 3 cm, which is the height of the cork. We now come to the video in Tracker. The motion lasted for some 15 frames. The image appeared pretty blurred, so we had to estimate the position of the center of mass. The total distance covered by the object was of 0.6 meters. We now come to the physics part of the motion. The two forces experienced by the body are first of all the weight, and you have the drag force. We tried to fit the experimental and observed data using two models. The first one, in which the drag force would be directly proportional to the velocity v, and the second one in which the drag force would be proportional to v square. Next we come to the codes used in VPython. The mass of the cork and parachute was measured to be 0.016 kg by an electronic balance as shown. The time interval delta t was set at 0.01 seconds. The value of the constant b was adjusted for both models until the final experimental position matched with the final modeled position. Here we can see the screenshot of the program for how the equations for fd and fnet was set. Finally, we come to the graph for model against experiment. The first graph we are going to consider is that for the drag force directly proportional to v. As we can see, only the last 4 points from the experiment seem to match the model. This can be largely due to the fact that the value of b has been chosen so that the final positions of the model and the experiment match. The second graph we will consider is that for the drag force directly proportional to v square. Here we see that there is a much better fit between the experimental data and the model. We can therefore conclude that taking the drag force being directly proportional to v square is much more appropriate to model the drag force.